Space is vast. It's filled with mysteries. For centuries we have gazed at the stars and wondered, what's out there? How did it all begin? The answers are shrouded in the distant past, but now we have new eyes to see. Powerful telescopes allow us to peer back in time. They capture light that has traveled for billions of years, and sometimes this light carries secrets. Recently, a faint signal was detected, a whisper from the dawn of time. The James Webb Space Telescope, or JWST, is the most powerful telescope ever built. Launched in 2021, it orbits the Sun, 1 million miles from Earth. It can detect incredibly faint light from the first stars and galaxies. JWST is helping us rewrite the story of the universe. It's showing us things never seen before. But it's not alone. A new mission, Sphere-X, will soon join the search. These telescopes work together. They help us unravel the mysteries of the cosmos. In the depths of space, a faint glow, barely perceptible yet unmistakably real, pierced the darkness. It was a whisper from the ancient cosmos, a flicker of light that had traveled across unimaginable distances to reach us. This signal, faint and ancient, originated from a time long before Earth even existed, a time when the universe was still in its earliest stages of formation. It's not just light, it's a message from the past, a cosmic postcard sent over 13 billion years ago. The James Webb Space Telescope, humanity's most advanced eye in the sky, was the one to catch it. Designed to peer deeper into space and further back in time than any telescope before it, Webb was built for discoveries like this. The light was traced back to a galaxy now known as JWST 13-1. It's not just far away, it's the most distant galaxy ever observed. What we're seeing is not what it looks like now, but what it looked like when the universe was still a newborn. The photons from JWST 13-1 began their journey more than 13.4 billion years ago. They've been traveling through the expanding fabric of space-time ever since, carrying with them the story of a galaxy that existed when the universe was less than 400 million years old. This means we are witnessing JWST 13-1 as it was during the universe's infancy, just a few 100 million years after the Big Bang. At that time, the first stars were igniting, and galaxies were beginning to take shape. It's a window into a time we've never seen before. For astronomers and cosmologists, this discovery is groundbreaking. It challenges our understanding of how quickly galaxies could form after the Big Bang. It raises new questions about the nature of the early universe and the processes that shaped it. JWST 13-1 offers a rare glimpse into a time when the cosmos was still assembling its first structures. It's not just a discovery, it's a revelation, a reminder of how much more there is to learn, and how far we've come in our quest to understand the universe. The early universe was a very different place. Just moments after the Big Bang, the cosmos was a seething, energetic expanse of particles and radiation. Temperatures were unimaginably high and matter as we know it had not yet taken shape. There were no stars, no galaxies, only a dense, hot soup of fundamental particles. As the universe expanded and cooled, protons and electrons combined to form neutral hydrogen atoms. This created a thick fog of hydrogen gas that filled the cosmos. During this time, light couldn't travel freely. It was constantly scattered by the neutral atoms, making the universe opaque to radiation. Imagine trying to shine a flashlight through a dense cloud of smoke. That's what the early universe was like, completely shrouded in a cosmic fog. This era is known as the Cosmic Dark Ages, a time before any luminous objects had formed to pierce the darkness, but eventually, gravity began to pull matter together. Tiny fluctuations in the density of matter led to the formation of the first stars and galaxies. These early cosmic structures ignited, flooding the universe with intense ultraviolet radiation. This radiation had a powerful effect. It began to ionize the surrounding hydrogen gas. That means it broke apart the hydrogen atoms, knocking electrons free from their protons. As more and more hydrogen was ionized, the fog began to lift. The universe slowly transitioned from opaque to transparent, allowing light to travel vast distances for the first time. This transformation marked a major turning point in cosmic history. This transformative era is known as the Epoch of Reionization. It began roughly 400 million years after the Big Bang and continued for several hundred million years. During this time, the universe was fundamentally reshaped by the light of the first stars and galaxies. Thanks to the James Webb Space Telescope, we're now peering deeper into this mysterious epoch than ever before. The signal from a distant galaxy, JWST 13.1, suggests that reionization may have started earlier than previously believed, perhaps as early as 300 million years after the Big Bang. This tiny but powerful galaxy was already emitting enough radiation to carve out a bubble of clarity in the surrounding hydrogen fog. It was helping to clear a path for light to travel freely, an early beacon in a dark and foggy universe. Just when we thought the James Webb Space Telescope had revealed all it could, it detected another signal. This one, came from a galaxy called JWST, also from the early universe, more than 13 billion light-years away. But JWST is, well, different. It's much brighter than scientists expected for a galaxy from that era, and it's forming stars at an astonishing rate. JWST really challenges our understanding of early galaxy formation. It might suggest that, hey, some galaxies evolved way faster than we previously thought. The discoveries of JWST 13.1 and JWST are, well, truly changing our view of the early universe. They suggest that things were more dynamic, more chaotic, than we ever imagined. Stars and galaxies, it seems, formed earlier and much faster than our current models had predicted. These discoveries, though, are just the beginning. With the James Webb Space Telescope, we are stepping into a whole new era of astronomy. An era of discovery and wonder. Scientists around the world are honestly buzzing with excitement. The discovery of JWST 13.1, one of the most distant galaxies ever observed, has sent ripples through the global scientific community. It's not just about the distance, it's about what this discovery represents. For decades, astronomers have theorized about what the universe looked like in its infancy. Now, for the first time, we're beginning to see it with our own eyes.
Dr. Kevin Hainline of the University of Arizona described the JWST 13.1 discovery as a beam of light piercing the veil. He explained that this light has traveled over 13.4 billion years to reach us, meaning we're seeing the universe as it was just a few 100 million years after the Big Bang. It's like looking through a keyhole into the past, he said. And what we're seeing is more beautiful and complex than we ever imagined.
Professor Roberto Maiolino at the University of Cambridge called it a key moment in understanding the early universe. He emphasized that this isn't just a single discovery, it's a doorway to a new era of astronomy. We're not just detecting galaxies, he said. We're beginning to map the structure of the cosmos at a time when stars were just starting to form. It's like opening a history book that was previously sealed shut.
It's like finding a hidden message in a bottle washed ashore from the distant past, said Dr. Emma Chapman, an astrophysicist at the University of Nottingham. She added that these early galaxies are not just scientific curiosities, they're clues. Clues about how matter organized itself, how the first stars ignited, and how the universe evolved from darkness into light. Each data point is a whisper from the cosmos, she said, and we're finally learning how to listen. These signals offer us an unprecedented glimpse into a time when the universe was taking its first steps. The James Webb Space Telescope is not just showing us distant galaxies, it's revealing the story of our cosmic origins. With every new image, scientists are rewriting what we thought we knew about the early universe. And as more data comes in, the excitement only grows. This is just the beginning of a new chapter in our understanding of the cosmos.
The findings from JWST are, quite frankly, challenging a lot of our assumptions about the early universe. They're forcing us to rethink how galaxies formed and how the epoch of reionization unfolded. The universe, it's full of surprises, and it's far more complex and wondrous than we ever imagined. These discoveries remind us why exploration matters, why pushing the boundaries of knowledge is so important. The James Webb Space Telescope is, honestly, just the beginning. New telescopes, like SphereX, are already in development. They'll continue to explore the cosmos, searching for answers to the biggest, most profound questions like, where did we come from? And, are we alone? The future of astronomy is bright. It's filled with possibilities. We are truly on the verge of incredible discoveries. The universe is waiting to be explored.